Turbo Machinery Pelton Wheel tutorial question number 4. A Pelton wheel with two jets produce power of 2 MW at 400 RPM. Wheel diameter is 1.5 meters. Gross height is 200 meter. Efficiency for delivery pipe is 90%. The relative velocity at outlet was decreased 10% from inlet, and the bucket angle is 165 degrees. Determine the net head, the Euler head, the hydraulic efficiency, and the diameter of the jet. So first, I hope you could list all the parameters from the question. We have the RPM here, the power output, the efficiency of delivery pipe. It is showing the major loss inside that pipe. So we have K, we have diameter of wheel here, we have angle, and we have beta 2 here. And I hope you need very sure to label the angle here. Means you could draw the velocity triangle very well. So this is the velocity triangle. So this is the runner, this is the bucket, and this is the velocity triangle at inlet, and this is the velocity triangle at outlet, and this is the location of beta 2, or it is equal to the angle of this area. First, we are calculating the net head. The net head is the effective head that hit the Pelton wheel here. So it can be calculated by using the gross head times the efficiency of the delivery pipe. So from the question, we know that the efficiency of pipe is 0.9. So from 200 meters, the effective head becomes 180 meters. Next, we are calculating the Euler head. This is the basic Euler head equation for turbine, and we use this equation in Francis turbine. However, in Pelton wheel, it is advantage for you to remember the Euler head for Pelton wheel as this term: U over G, V1 minus U, 1 plus K cos beta 2. And then we need to get the value of U, the value of V1 or V jet, and the value of K and the value of beta 2 to calculate the value of Euler head here. From this equation, U equal pi dn over 60, we could calculate the value of U, or wheel velocity, is equal to 31.4 meter per second. Then we could calculate the velocity of jet by using this equation, because we already know the value of effective head, which is 180. And in this question, we don't have any value of CV. So we assume it is equal to 100%. So we put 1.0 here, and we could calculate the velocity of jet is equal to 59.43 meter per second. And from the question, we know that the value of K is 0.9 and the angle is 15 degrees. So we substitute in this equation of Euler head, we could get the Euler head is equal to 167.71 meters. Next, we are calculating the hydraulic efficiency. So the basic equation of hydraulic efficiency is power at outlet divided by power at inlet. And to calculate the hydraulic efficiency, we use the Euler head at the outlet and effective head at the inlet, and then we could we could cancel out the value of rho GQ. So it is okay for us to calculate the hydraulic efficiency by dividing Euler head over effective head. We know that the Euler head is 167.71 and the effective head is 180. So we could calculate this amount, and the hydraulic efficiency is equal to 93.17%. You may also use this equation to calculate the hydraulic efficiency, or in some textbooks, they will use this kind of equation, which phi here is the speed ratio, which is equal to U over V jet. Now we are calculating the diameter of jet. From the question, we know that the power output is 2 megawatt, and we assume the efficiency of mechanical is equal to 1.0 because it is not clearly stated in the question. From the equation of mechanical efficiency, we could calculate the flow rate. The equation will become power out over rho g mechanical efficiency and Euler head. And please remember that in mechanical efficiency, Euler head will become the input, and the power output always given in the question. So from this equation, we could calculate the flow rate is 1.216 meter cube per second. Because we have two jets, the flow rate for one jet is equal to 0.608 meter cube per second. We could calculate the flow rate for one jet by using this equation. Q equal A times V jet, which is A here is the cross section of the water jet. The equation of A here can be written as pi d squared over 4. We substitute all the value here. We could calculate the value of D, the diameter of jet, is equal to 0.114 meter.